Okay, so Cheryl, everywhere you look, you hear about quantum computing, especially in finance. It's almost always framed as this magic bullet, right? Like it's gonna, solve everything, make everyone rich overnight. Is that actually what's happening? Oh, Heidi, you hit the nail on the head. Absolutely. That's totally the vibe, isn't it? The headlines just love to sensationalize, like market solved by qubits. But the reality, it's way more nuanced. We're talking about a tool, a specialized tool, not a universal panacea. It's not replacing classical computers entirely. The thing is, it's for these super specific, complex bottlenecks that classical stuff just struggles with. We're still in what they call the NISQ era, noisy intermediate scale quantum. So fault-tolerant machines for Wall Street, years away. It's really about hybrid quantum classical workflows right now.
Hybrid, so it's not a takeover. More like a superpowered assistant then?
Exactly. An assistant for the really, really tough high-dimensional problems, not the everyday stuff. Okay, so if it's not for everything, where does it really shine? Like, what kind of tough, high-dimensional problems are we talking about here? Great question. The best analogy I've heard is thinking about portfolio optimization not as a spreadsheet, but as a multi-particle system, like in physics. Modern markets have billions of variables, super intricate correlations, real-time risk. It's just this incredibly complex interacting system. Classical computers, they start to approximate, they simplify things just to cope. But quantum algorithms, oh, they absolutely excel at that. They're built for complex optimization and pattern recognition. Think about quantum annealing or QAOA for portfolio optimization. They can explore these vast solution spaces, handling tons of assets and constraints simultaneously, finding optimal solutions that classical systems just miss or take forever to find. It's really a different way of looking at the problem, leveraging quantum mechanics itself. Wow. So it's like classical computers see a flat map and quantum computers see a 3D, ever-changing landscape? That's wild. Precisely. That's a great way to put it. It's for when classical starts to, well, break down.
Okay, so when do classical systems actually start to break down, like for real? And what are financial institutions actually doing with this right now? Like, are there actual banks using this?
Totally. Classical systems start struggling big time with extreme uncertainty and vast portfolios, where quantum can process many states simultaneously. Great for risk modeling, right? And those computationally intensive problems that just overwhelm traditional computers, quantum thrives there. Monte Carlo simulations, which are huge for options pricing, quantum could reduce those from hours to seconds, seriously. High-dimensional interacting data, like for granular risk simulations or fraud detection, that's another area where classical kind of falls short. And cybersecurity. Future quantum computers will actually threaten current encryption, so developing quantum-safe encryption is a huge focus. So practical applications? The industry is heavily investing in risk management and cybersecurity, portfolio optimization, derivative pricing. JP Morgan Chase, for instance, is totally at the forefront, partnering with IBM and Amazon to explore these algorithms. It's not a wholesale replacement, it's really about strategic deployment for the most intractable problems.